Okay, so this is a quick demonstration of the Layer 2D software that's designed to analyze layer-wise printing accuracy of 3D printed foods. So here in the demo version, we can select an image from the available demo files. In this case, we'll use the cookie, the block cookie design. And we'll also need to select the corresponding G code from the demo files as well. It's this one here. And with this, we're able to, the software is able to specifically locate where the area of interest is, and that's based upon the G code positions. And we leave about a 5 millimeter edge so that it doesn't directly crop into our design. And so then we can just leave this as at 5 millimeters for now, and we can click overlay G code, which will give us the preview of our overlaid G codes. So as we can see here, there's some well, it's the G code is the red image overlaid on top of the obtained layer image. There's some mismatches here, but we'll be able to take care of it in the subsequent steps. But now this is just a quick check that we selected the right image and the right G code. So overall it matches. And then the next step is really because we have multiple area of interest, we have multiple structures printed in this picture, so we can select a specific area of interest based on the overlaid image that we just saw. So in here, we're able to click and drag to select a given cookie. For example, this time I just selected the one on the left. And with this, if we hit Q, it will perform the analysis and give us a quick overview of the over and under extrusions based upon the G code analysis. And now what we can see is that the G code has already been aligned with the image so that we're able to get the true over and under extrusion per layer. And if I cross it out, if you look at the Python console, and in this case I'm running it in PyCharm. The software also returns the over and under extrusion fractions. So in this case is about 16% over extrusion and about 5% under extrusion. And with this, we're also able to visualize the under and over extrusions on the original printed image. So if we click Visualize Under Extrusion, we're able to see the highlighted yellow area as the missing printings. So the missed prints or kind of align the infill lines and a little bit on a corner here for this particular cookie. And we're able to also do the same for over extrusion. And because over extrusion occurs at various degrees, what we have is a heat map approach where we look at a given size of a grid and the severity of over extrusion within the grid. And in this case, if we click the grid analysis, what we're able to see is that the heat map highlights where the severity of over extrusion is by its intensity. So for example, here we have a little bit of oozing that carries the most over extrusion here. And also at the beginning of the print, the start and stop points where it's aligned, it's also a bit over extruded due to the extra pushings and stuff happen here. Okay, and the last bit of add-on features of the software is to calculate the infill of a closed structure. For example, in this case, the block is filled by some rectilinear lines, and we're able to calculate the porosities of these structures. So here we return to the original image, and we can just click and select the area of interest, and then we're able to calculate the for this specific cookie the porosity, or I should say the filled area, so the solid fraction is about 78.4%. And we can do the same for the G code, where this is the standard G code that's simulated from the G code script. And we'll also select the same cookie and hit Q to run the analysis. What we see here is that the actual G code has a 76.8% of solid fraction. So these are quite close to each other, meaning that this is quite nicely printed of a structure if we evaluate it based on the infills. So there you have it. This is just a quick showcase of what the software is able to do. And on the GitLab link, we have more requirements about the how to obtain the pictures and how to slice the G codes from your STL files. And hopefully this can help you with your future research.